Use integers and rational numbers. All right, so you've probably heard like there are different names for different types of numbers before. So just as a kind of quick review, whole numbers are basically like our counting numbers. So they start at, well, they can start at 0, but 0, 1, 2, 3, so on and so forth. Integers are basically the whole numbers plus their negatives. So we could go like in each direction, like -3, -2, -1, 0, 1, 2, 3, and so on and so forth. Okay, anytime we do like a dot, 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 that just means it's continuing on in like basically either direction. We also have something called a rational number. Or rational numbers, which are numbers like for like a over b, where a and b are integers. The only catch is that b is not equal to 0, okay, because we cannot have something divided by 0 that's undefined. Maybe that comes in another section. Okay. And then just as like a diagram for you, basically whole numbers are integers, but not all integers are whole numbers. All integers are rational numbers. And then the overarching of all of this is real numbers. Okay, you're probably like, aren't all numbers real? Well, as far as you know at this point, yes. However, we do have something called imaginary numbers that you learn about later in math. But if you see this little poster up here on the wall, the little dude that's a pi is saying get real, and then the little square root of -1 guy is saying be rational. At this point, irrational numbers, we're not talking about, that comes in like the next section, but irrational numbers are numbers that go on forever. Rational numbers are basically numbers that like have a definite ending point. We can have terminating or repeating decimals. You've probably talked about those before, but like if we took 1 divided by 3, that would be 0.333333, and it goes on forever. Okay, that's a repeating decimal. But if I did something like 3 divided by 4, that's equal to 0.75. That's a terminating decimal. But both of those are rational numbers as well. Irrational is like pi. There's no point where it repeats. There's no point where it stops. It literally just goes on forever. For reference, just a portion of pi is written on that eye chart thing on the far side over there, because there's infinite amount of digits, but that's just obviously a chunk of them. So irrational numbers or something like that go on forever. But again, that's another section. Some of these questions are going to ask you to essentially use a number line to tell which number is greater than or like the other one. I taught it that way last year, and everybody was thoroughly confused on like putting them on a number line and determining which one was greater. So we're probably not going to do that. We might plot them on the number line, but I would hope that you can figure out what number is bigger or not. Sometimes you might be asked to classify a number as a whole number, an integer, a rational number, and then it might tell you to order them from like least to greatest or greatest to least, something like that. So just so that we're aware. Now, if something's a whole number, is it also an integer? Yes. If it's a whole number, is it a rational number? Yes. Just because it's a rational number, though, does that mean it's a whole number? No. Okay? So we'll just have to watch for that as we do those problems. Some other stuff in this section, absolute value. So when we hear absolute value, we should think of distance from 0. So it's how far away is that number from 0. So anything inside of an absolute value is going to become positive because that's how far away it is from 0. So if I have something like the absolute value of a positive A is equal to A, that's one option. If A is 0, so this is if A is positive. Let me do this. A is positive. If A is 0, then the absolute value of A is equal to 0. And then if A is negative, then the absolute value of A is still A. So as numbers go, so that this isn't like confusing, basically, for an example here, if I have the absolute value of 8, that's equal to 8. Okay? That annoys me. If I have the absolute value of 0, that's equal to 0. But the absolute value of negative 2 is equal to positive 2. Let's see. All right, something else that these we'll spend a lot more time with in geometry, but obviously not this year, but just so that we're aware, and there's a few of them in this section, are conditional statements. You've probably heard these off and on throughout your life and never really realized what this meant, but this has a hypothesis and a conclusion. So, we also sometimes refer to them as if-then statements. So we could have something like, if it doesn't rain today, then I'm going to go to the park. Okay, that's an if-then statement, a conditional statement. But obviously we can have them in math as well. And the way that we prove that one is wrong is by finding a counterexample, which is basically just finding an example that proves that the statement is false. So if you had one like, say, for example, if a number is a rational number, then the number is positive. Well, is that true? Why? What would be something that would prove that this is not true? Yep, rational can be positive or negative. So a counterexample would be negative 2/3 is rational and negative. Now, what if I changed it and I said if a number is a whole number, then the number is positive? Is that true? Yes. So that would always be true. So that would just be a true statement. Let's see. All right, getting into examples here. Graph the numbers on a number line, then tell which number is greater. So you should be able to tell which number is greater because these are all like integers just by looking at them. But we'll plot a few of them on a number line just for reference. So I have the number 0 and -4.
These ones, do you want us to solve them or no?
If they just say to write the equation or inequality, you don't have to solve them. All right, so on a number line, we would set this up. So I've got 0 over here, counting by ones. And you don't necessarily have to put all the numbers on there. So I have a number at -4, and I have one at 0. Okay, so which number is bigger? 0. So whichever number is the farthest to the right should be the biggest one. So like I said, I'm not super worried about you plotting the numbers on the number line. As long as you can tell me which number is bigger, that's the main thing I'm worried about. How about 8? -2 and -3. Which number is bigger? Yep, -2. So if we looked at this on a number line, just for a visual for a second, got 0, -1, -2, -3. Then I've got my two numbers on here. -2 is the one that's farthest to the right, and so that would be the biggest one. All right, I trust we're okay on that. Cool. Okay, classifying and ordering numbers. Tell whether each number in the list is whole, integer, or rational, then order the numbers from least to greatest. So what I would tell you here is to abbreviate whole numbers as a W, so you don't have to write the word out every time. Integer as an I, and then rational as an R. Now, we don't have irrational right now, but when we get to irrational, which is in a later section, since integer and irrational both start with I, what I do is I make irrational I with a little r. Okay, and then I just leave integer as just an I. So just so that y'all see how I do that. If you want to do something different, that's fine, but that's how I abbreviate them. Just make sure that it's like something clear. Don't be like, oh, well, A is for whole numbers. Like, that doesn't help me. Like, use the letter from the word. But if you want to write the whole thing out, that's also totally fine. I don't care. All right, so they give us a sequence of numbers. So 3, -5, -2.4, and 1. And they want us to write them in numerical order. Okay? So which one is the smallest? -5, then what? -2.4, then +1, and then lastly, +3. So now, I have them in order. Now I need to classify them. Okay? So how would I classify -5? Well, is it a whole number? Nope. Is it an integer? Okay, so I'm going to write an I. And then is it rational? Yes. So if it's either whole or an integer, it also is rational. Okay? But just because it's rational doesn't mean it's the others. How about -2.4? What do we think that one is? Yep, that one is just rational because it's a decimal. Pretty much if it's a decimal or a fraction, it has to either be rational or irrational, but right now all we have is rational. What about 1? Yep, it would be all 3, WIR. And 3, obviously, same thing. All right, now those numbers were pretty nice, right? Sometimes they aren't so nice. 18. -0.01, 0.1, 0, and -1/10. Are these ones as obvious? What's the smaller and what's the bigger ones? No. Okay. This is where sometimes a number line will be helpful. I would suggest overall that if you have fractions, unless they all have the same denominator, that you make them into decimals. Okay, I think it's the easiest way to probably do it. So, do we know what -1/10 is as a decimal?
-0.10.
Yep, -0.1. Okay, so I would look at it like that. As far as like putting them in order. Now, when you write your numbers in order, you need to write the original number from the list. Okay? So I'm not going to write -0.1 when I'm doing my order from least to greatest. I'm going to do -1/10. Okay? Because I won't always have them written down when I'm checking quizzes and tests as to like which one it is. So make sure you always put them as whatever they were originally. So what is the smallest number that I have here? -0.1. Okay, that's going to be farther to the left. So this is going to be -1/10. Then what? Yep, -0.01, and then 0, and finally 0.1. So now I need to go through and classify my numbers. So what is this first one? Yep, just rational. What about this one? Yep, just rational. How about 0? Yep, WIR. And 0.1? Yep, just rational. So if they give you like some decimals and then some fractions, I would just say convert all your fractions over to decimals. If you want to convert your fractions into mixed numbers, if they're like improper, that might be an easy way for you to do it also, but I still think it could be easier if you just convert them all to decimals when you write them. But any questions on those? All right, for the given value of A, finds -A and the absolute value of A. So with these ones, so we're finding -A and the absolute value of A. So 24, A is equal to negative 3. So if A is negative, then I have negative A is equal to negative times negative 3. And so that ends up being a positive 3. Okay? The absolute value of A is the absolute value of negative 3. Well, the absolute value is always positive, and so this would also be 3. So both of those numbers would be 3. All right, 26. A equals 0. Are you done? Okay, you can just sit right there. All right, A equals 0. So negative A is equal to, well, can 0 be negative? Nope, 0 is just 0. So we just put it as 0. The absolute value of A would be the absolute value of 0, and what is that? 0. Let's see. $28. A equals 2.7. So negative A would be equal to what? Negative 2.7. And then the absolute value of A is the absolute value of 2.7, which is just 2.7. All right. Analyzing conditional statements. Identify the hypothesis and conclusion. So, if I did it with, say, this one up here, my hypothesis would have been if a number is a rational number. Okay, that would have been my hypothesis. Then my conclusion would have been then the number is positive. Okay, so this part would be my conclusion. So they want us to identify those two things. Okay, so if you have highlighters and you want to highlight and then just show it that way instead of having to rewrite the whole thing, you want to underline it when you do it, whatever, that's fine. Then they want us to say if it's true or false. So like this one up here was false, and so we provided a counterexample for it, okay, to show that why it was false or what would make it true if we redid it. So 36, if a number is negative, then its absolute value is negative. Just going to abbreviate it so it's... All right, so my hypothesis is if a number is negative, and a lot of times I just do HYP for hypothesis, then the conclusion is then its absolute value is negative. Is that true? No. Okay, so this is false. So we need a counterexample to show. So I would say do something like the absolute value of -4 is equal to +4, and that would show that this is false. Okay. Um, 38. If a number is an integer, then the number is a rational number. I'm just going to say then it is a rational number. All right, so what's my hypothesis? Yep, if a number is an integer is my hypothesis, and so then my conclusion is the stuff that's left, then it is a rational number.
That's true.
It is true. Because any integer is also rational, so all you need to say on this one is true, and you don't have to write anything else. All right, any questions about this stuff? All right, so some problems then for you to work on. 7, 13, 15, 19, 21, 27, 29, 35, and 37. And you've got 20 minutes. You should have plenty of time to knock that out.